In this demo, we will learn how we can tackle array keys and composite keys. We're back in our author collections controller. With an array key, I mean that the key is a comma-separated list, like 1, 2, 3, if you're working with numeric keys. With a composite key, I mean that the key is a combo of key value pairs, like key 1 equals value 1, key 2 equals value 2, and so on. I combined these into one demo because the question is more related to URI design than implementation. We need an array key for our location header when creating an author collection, so let's start with that. There isn't a standard that states how to work with this, but what is often done is using round brackets containing the comma-separated key. In our case, that would mean passing through a comma-separated list of GUIDs. Let's store them in an author IDs variable. This author IDs parameter is an array of GUIDs, but there is no implicit binding to such an array that is part of the route. There is for simple types, like strings or ints, but not for GUIDs. We could, of course, accept an enumerable of string here and cast it afterwards, but for the demo, I'm going to try something else. We're going to create a custom model binder. It is a deep dive course after all, right? We will also need to use the fromRoute attribute to ensure that the framework gets the value from the route. By default, it looks in the body for collection items. So that's easy to fix with this fromRoute attribute. The custom model binder will require a bit more work. Let's add a new class to the helpers folder for that. We'll name it Array Model Binder. That's defined in Microsoft.ASP.NET Core.MVC.ModelBinding. So let's import that namespace and let's implement this interface. Only one method to implement: bind model async. The model binding context is what we will be working with. It contains information about the model binding that we can use and set. The first thing we want to do is ensure that our model binder only works on enumerable types. After all, that is what we want to use it for. We can do that by checking the model metadata on the binding context. It contains metadata about the incoming type, like whether or not it's an enumerable type. A lot more metadata about the model can be found and logic can be written against it if you need it by checking out the model metadata property. So, if this isn't an enumerable type, we state that model binding failed by setting the result to model binding result.failed. Seeing we need to return a task from bind model async, we return a completed task. Then we need the inputted value. We can get to that value via the value provider, on which we can call getValue, passing through the model name. If that value is null or white space, we want to set the model binding result to null. That's also what often happens with the default model binders. If the incoming data is null, the result of the model binding is also null. It's still considered successful, so other parts in the pipeline can react to this. We actually saw an example of this already when we previously tried to post to the author endpoint with an empty request body. In that case, internally, model binding was successful, which then, thanks to the API controller attribute, allowed the framework to return a problem details object in the response body. Anyway, there's more we need to check. If the value isn't null or white space and the type of the model is enumerable, we need to get the enumerable's type. For that, we call into getTypeInfo from the system.reflection namespace. So yes, indeed, we are using reflection here. In fact, the ASP.NET Core framework uses quite a bit of reflection for serialization, deserialization, and things like model binding. Once we have the type, we need a converter so we can convert the items in the value list to the enumerable type. We get a converter by calling getConverter on the type descriptor class, passing through the element type for our converter. Then we convert each item in the value list to the enumerable type. This means that what we're now doing is taking each piece of string that was inputted via the URL, which is in fact a GUID, and we are trying to effectively convert that to a GUID from the string. If conversion of all these values was successful, we create an array of this type and we set it as the model value on the binding context. That means that binding was successful, which means we can now also set the result to a successful model binding result, passing through the model in the end. We're now done, so we return a completed task. Let's save this. This is our custom model binder. Now let's make sure we use this. We want to use it to bind the author IDs from the URI to our IEnumerable of GUID. We can do that with the model binder attribute, passing through the type of our array model binder. Then let's implement this method. First, we get the matching authors from our data store via the repository. For that, we can use the getAuthors_async method, passing through the IDs. One thing that's important to check here is whether all authors have been found. If not, this is an invalid key and we should return not found. If that checks out, we map the entities to author DTOs and we return them with an OK status code. That's it as far as implementation of this action goes. We will need to be able to refer to this route from our method that creates an author collection, so we can create a URI for the location header. So let's give this a name. Get author collection. And then we can scroll down a bit. We're now in our create author collection action. We're going to get rid of this return OK statement here. First, let's create the content for the response body, which is an IEnumerable of author DTO. There's nothing new here, we simply use AutoMapper for that. But we also need a list of IDs, as that's our key. We can use a string.join statement for that, after selecting the IDs from the collection. With that, we have all we need. We can now use the created @route helper method, passing through getAuthorCollection for the route name, an object with the list of author IDs, and the author collection to return for the response body. That should be it. Let's build and run. We're back in Postman, and we've got that request from the previous demo, which we sent to create one author collection, lined up here. Previously, it returned a 200 OK. Let's see what happens now. We get back a 201 created with the 2 authors in our response body. Let's have a look at the headers. There's a location header here, which contains a key with the 2 GUIDs of the newly created authors. Let's try navigating to that. So we send the GET request. And there we go, our author collection we just created. Okay, so this works. But what about composite keys? A composite key consists of multiple key value pairs instead of a list of one field. This is a requirement that sometimes comes up in systems when there is no simple one-on-one mapping between the outer-facing contract and the backing data store. A pattern that's often used is what you see on screen here, providing a key value mapping in the URI. In other words, a combination of the keys you need to return the correct resource. We have not got an example of such a resource, but we already know how to implement something like this. Simply use a route template with 2 keys, in this case, that map to 2 parameters in the action signature. This is supported out of the box. There's one more thing we have to handle, or rather protect against, as far as working with post is concerned. posting to a single resource. Let's check that out next.